Hi, welcome. We're going to look at the nth root and rational exponents. So we're starting up a new chapter here. The nth root notation is something we've already been working with, but it's been limited to just the square root. So we're familiar with this. We know that this really just means, if you see this little square root sign, it just means, hey, there's what number raised to the second power is going to be equal to 9, or what number times itself equals 9, and we know that that's going to be equal to 3, which means the square root of 9 is equal to 3. And there is a little number here, it's called the index, and the index tells you how many times you want to multiply this number by itself to get what's called the radicand, or the number underneath this thing, how many times you need to multiply itself to get there. So the nth root notation can have different roots. We do have something called the cubed root, and the fourth root, there's a fifth root, a sixth root, a seventh root, any integer root out there. Now, we're also going to look at rational exponents, which rational generally refers to some sort of fractional notation. So 1/2, 1/3, 1/4, those are all rational numbers. And how we can kind of look at those in a different way. 9 to the 1/2 power, if you just grab your calculator here, type it in, little up arrow, make sure you put the powers in parentheses. So 9 to the 1/2 power also equals 3. Okay, so 9 to the 1/2 equals 3, whereas the square root of 9 equaled 3 also. Okay, so is there a coincidence there? I don't know. Let's figure this out. The cube root of 8. Okay, now it's going to ask a different question, but this one's just going to say, hey, what number do you need to multiply by itself 3 times, or what number cubed equals 8? Okay, and if we think about our times tables, 2 times 2 times 2 is 8. So 2 cubed equals 8, which means the cube root of 8 is going to equal 2. Okay, well, if we look at 8 to the 1/3 power, grab a calculator, type it in, 8 to the 1/3 is going to be 2 also. So if we look at the cube root of 8, well, number times itself 3 times equals 8, we get 2. Or if we take 8 and raise it to the 1/3 power, we also get 2. Okay. Now, there is the cube root button, and to get there from your home screen, you have to hit the math, and then down to number 4, and it's got the little cube root of something button. So cube root of 8 is also going to equal 2. Okay, so I feel it's a lot easier to work with the rational exponent than the root, but that is up to you. If you want to go into the catalog there under math and get those values, you sure can. But let's take a look at the last one here. It says the fourth root of 1,296. So we'd be looking at trying to find what number times itself 4 times equals 1,296. So we can do that here as well. To do any number other than the square root and the cube root, we have to type the index in. So we put the 4 in. Then we go into that math catalog, or the math options there. Scroll down to the xth root, okay, and we already put the 4 in, that's what stands for, the x there. And then we type the number, 1,296. Okay, we don't put parentheses in this, you just hit enter at that point, and you'll find out that that answer is 6. So 6 raised up to the 4th power, 6 times 6 times 6 times 6 is 1,296. Okay, let's see if that happens here also. 1,296. If we raise that up to the 1/4 power, we get 6. Okay, so here's what we're finding. We're finding that each of these roots we looked at, each of these nth roots, each of the second root, third root, fourth root, had the equivalent exponent. Okay, and that's one of the big connections that we're trying to put together here with these roots and these rational exponents. So if we come up with a summary, we'd say something along these lines. Every nth root has an equivalent exponent, or rational exponent. Okay, and to summarize that a little bit further, just kind of with some notation here, we could say if it's the nth root, so that's whatever the index is, 2, 3, 4, 5, whatever, of some number a, that's going to be equal to a to the 1/n power. So we can see that the index there is what the denominator of your power becomes. Okay. So let's move on here. Now these rational exponents can take on a little bit different shape or form. They can have, a numerator that's not 1. They could have a denominator, of any number other than 1. But anytime you have any sort of fractional power or any sort of rational exponent, we can convert between the two. So a to the mnth power is the same thing as a to the 1/n to the mth. Okay, so that's just using those properties of exponents we've worked with. This is a power to a power, so we'd multiply those. M times 1 over n is m over n. And then the 1 over n we know is equivalent from that little discovery above to the nth root of a. Okay, so we have the nth roots here and the rational exponents here. Okay, so there's an equivalent form for each one. We'll try to do some manipulation from one to the other as we progress through here. The second definition is just telling you what to do with the negative exponent. Again, we already know what to do with that. We just put 1 over the top of it and then break down the rational or the fractional power the same way. So it becomes 1 over a to the mn, 1 over a to the 1 over n to the m, and then the 1 over n power is the nth root of a. Raise that then to the m. So here's what these next problems are going to ask us to do. It says rewrite the expression in nth root notation, then simplify. So we want to first change the form and then reduce it down, because you could just take your calculator, plug this in 16 to the 5/2 power, and you get what we're looking for. But that's not what the directions are saying to do. So here we go. Put it into nth root form first, which has the square root sign in it, or the nth root form. So we would just kind of pull this thing apart, pull this power apart. We want to get 1 over some number as an exponent. So we'd make this 16 to the 1/2 to the 5th. So remember, the denominator becomes 1 over, and then the numerator is just the power raise it up to. And then to switch into the nth root form now, remember 1 over 2 power, the half power, is the same thing as the square root of 16. And then that's raised to the 5th power. So we can evaluate this now. The square root of 16 is 4. Raise that to the 5th. And then 4 to the 5th. If we plug that in the calculator or just type it in, it's 1024. Okay. So we'd be looking for both this notation right here. That's the nth root notation. And then this would be the simplified answer. Okay. Take a look at B here. 3,125 to the 2/5 power. And see what we can come up with there. Let's, again, break it down. It becomes 3,125. Okay, we're going to raise that number to the 1/5 power. Okay, that's the denominator. And then we're going to raise that to the second, or square it. So power to power, remember you multiply, so that'll break down pretty nice for us. I'm not sure what this is off the top of my head, so let's just go ahead and type that in, 3,125, or sorry, scratch that, we got to get this into the nth root. Remember, the 1/5 power is really the same thing as the 5th root. So we'll put it as the 5th root of 3,125, and then that'll be squared. And then we can simplify. So to do the 5th root, remember you go 5, math, x the root, and then 3,125, hit enter, and I goof that up by putting the parenthesis in there. Good little hint here, if you want to retype what you had in there, hit second enter, and it re-puts it in there, and then you can edit the value, but we'll end up seeing that that's just 5. So the 5th root of 3,125 is 5, and then we'll square that, which we can do in our head here to get 25. Okay. So think about this. The power we raised the power we raised a to was the 5/2 power, which is greater than 1. And this number took 16, raised it to the 5/2 power, power bigger than 1, and turned it into 1,024. And we know powers make things big relatively quickly. But we know negative powers can make things smaller, not necessarily negative, but smaller. But if we look at this power, the 2/5 power, we can see that actually took 3,125 and shrank it down to 25. And the reason for that is this thing has a power that is less than 1. Okay, so power greater than 1, it should grow the number. Power less than 1, it should shrink it or make it smaller. All right, so here we go. Let's see if we can't change these around. Let's go the other direction. And let's see if we can rewrite these expressions in rational exponents, and then we'll simplify them. So let's see. We have the cubed root of -8 to the 5th. This is no longer an issue. We can actually take the cubed root of negative numbers. So math, cubed root, -8. Make sure you close the parentheses of the cubed root. And you do get -2, which makes a lot of sense. And 3 negatives multiplied together gives us -8. So that's perfectly fine to do. So if this number is odd, a negative under here is no longer meaning complex or imaginary. So if it's even, then we have an issue with the negative numbers. But that's really besides the point here. What we're looking at doing is just rewriting this right now into rational exponent notation. So we want to get rid of the nth root, which we know we can turn a cubed root into a 1/3 power. Okay, the 1/3 power turns into, or the cubed root turns into a 1/3 power. And then we have the power to power, which we can just multiply those together. So we'll get -8 to the 5/3 power. Okay. And there it is. There's the rational exponent that's equivalent to this nth root. Now we can simplify that by just typing it into the calculator. Negative 8 to the 5/3 power. And that becomes negative 32. Okay, again, power bigger than 1. 5/3 is more than 1. It was a negative base, which gives us the negative number there, but it did grow the value as well. It makes it bigger. Okay. For looking at b here, this one doesn't have an actual radicand. It's just got x in there, which is a variable, so we can just get this into rational exponent notation, and that'll probably be it. But the equivalent power to the fourth root is a 1/4 power. So this could be x to the 1/4 to the 5th. And then it's just properties of exponents. We can change that into x to the 5/4 power. And no more simplifying can be done. We can't type that into the calculator. We're good to go.